So why don't you try this? Why don't you try this for, why don't you write, I should say, the chemical equation for the reaction that refers to the standard enthalpy of formation of carbon dioxide. Now I'll help you with the carbon. I'll help you with the carbon part. Actually, I want to just help you with the whole thing. So we're going to write the standard enthalpy of formation chemical equation for the formation of carbon dioxide. We want to make carbon dioxide as the product. And we're going to make it CO2. We'll make it CO2 gas. Now, it turns out that solid carbon in its standard state is graphite. The stuff that you find in pencil lead. What do you suppose this is going to react with to give us CO2 if we're writing the standard enthalpy of formation? We need oxygen in its standard state. How does oxygen normally exist at this temperature and this pressure, at room temperature and room pressure? Well, O2 gas. It's a diatomic molecule. So we would write this plus O2 gas. And what's really nice about writing the standard enthalpy of formation for carbon dioxide gas is when we write it in, it's already balanced, right? We've got one carbon, and we've got two oxygens going to carbon dioxide gas. And what's nice about this is I can look up the enthalpy of this particular reaction. I can look it up in the text, in your text. And you can look this up online. You can find these values all over the place. And if I look, I'm in Appendix L, Selected Thermodynamic Values. I just go through the list. I see here at carbon. I'm on Appendix, it looks like A27 is the page that I'm on. I'm starting to look through carbon. And at the top of this table, the first column has this symbol there. And it's listed in units of kilojoules per mole. So I just look at these various species, and as I look down, there it is, CO2 in the gas phase. And if I look at CO2 in the gas phase, and I move across one column underneath the standard enthalpy symbol, delta H subscript F superscript 0, I see a negative 393.509. And so therefore, I know that this particular reaction, the formation of carbon dioxide gas from 1 mole of oxygen gas and 1 mole of solid carbon graphite, if this reaction were to go, for every mole of this that's produced, there's going to be 393.5, roughly speaking, kilojoules of energy released per mole of CO2 gas that's produced. And these are listed for an enormous number of different compounds in Appendix L. Now I want to give you some clues here in Appendix L. You can actually use Appendix L to figure out what the elements are in their standard states. So for example, right at the top of page A27, right beneath carbon, if I look at carbon solid graphite and I look for its standard enthalpy of formation, I see that it's 0. And that is the clue to me to tell me that this is the standard enthalpy of, this is the standard state of carbon because of this fact. Watch this. Let's say that I want to know the enthalpy of formation in kilojoules per mole for the formation of solid carbon in its graphite form. I need to make this from carbon in its standard form, which just happens to be this. So I'm going to start with solid carbon graphite, and I'm going to go to solid carbon graphite. In other words, there's no chemical change going on. The stuff you're starting with is the same stuff that you're ending up with. And so if I have the enthalpy change, the standard enthalpy of formation for a substance that's already in its standard state, there's no change. And so anytime that you go through this chart, if you're confused about what is an element in its standard state, let's say, what's chlorine in its standard state? I don't know. Well, I'll look in this chart. I'm going to look under chlorine, and I see 5 different species under chlorine, and I just look for the one that has the 0. There it is. Under enthalpy, there's the 0, and I look at what chemical corresponds to that, and it happens to be Cl2. So because the standard enthalpy of formation of diatomic chlorine gas is 0, this would be the standard, this would be the standard state of elemental chlorine. So why don't you try this for, let's see if you can look this up, say for bromine. See if you can look through this chart and figure out what is the standard state for bromine, the standard elemental state for bromine. Well, if you look through the chart, if I look through here through bromine, I see this particular chemical species, bromine, diatomic. In the liquid phase, this would be the elemental standard state of bromine. Okay. So let's try writing a chemical reaction. Why don't you try write the chemical equation that corresponds to the enthalpy of formation of gaseous water. All right, if I'm gonna try this, if I'm going to write the standard enthalpy of formation for the formation of water, gaseous water, that's going to be my product, H2O gas. And 1 mole of it's going to be my product. Now I'm going to need to make this water from the elements in their standard states. So I'm going to look through my thermodynamic values. I'm going to look for the chemical species for which the enthalpy of formation is 0, and I'm going to write those as my reactants. And if I go through the chart, I'll see that the elemental form of hydrogen is H2 gas, and the elemental form of oxygen is O2 gas. And then the final step in the process is making sure that your equation is balanced. But doing so, making sure that you always have 1 mole of product, because that's what the standard enthalpy of formation always refers to, is 1 mole of product. And so I see that I have 2 moles of hydrogen atoms on this side because H2, that matches what I have in the product. But over here I have 2 moles of hydrogen atoms in the reactants, but only 1 mole in the product. So if I take half a mole of oxygen gas, then I end up balancing this particular chemical reaction. And if you look at the chart, for hydrogen, if I look through the chart, for H2O gas, the standard enthalpy of formation for 1 mole of formation of hydrogen gas is minus 281.83. I think I got that right. Yep. Oh, sorry, 241.83 kilojoules for every mole of hydrogen that's going to be produced.